without further ado, I'm going to let the floor to audio folks with Michel.
Thanks, François. So my name is Michel Buffat. I am from the University of Nice on the French Riviera. And I will talk about interoperability, reusability of high-level web audio component. By high level, I mean a synthesizer, a complex effect, not just a filter or just a small, gain setting or something like this. So this is me in my office with another researchers from CNRS, and this is what we are doing. I'm in charge of I'm the national coordinator of a big research project, and we are dealing with composers, musicians, music school, with Deezer, with streaming services, and so on. Just a small view of what we are doing. This is a guitar teacher playing guitar. Everything is done on the web here. Yeah, nice setup for listening to MP3s. Okay, that was just to give you an idea. So there you saw a guitar amplifier simulation. We recreated the whole electronic schematic of an amplifier on the web, multi-track player, and so on. So usually when I go to conferences, this is my room in the hotel, but here I came light. Because it was not really a conference about audio and music, but everything you saw was real time, so we can play real time keyboards, guitar, and such things. So here are some impressive web audio development that you can find on the web today. You can find many synthesizers, some vocoder. Chris Wilson has wrote a very nice vocoder, some digital audio workstations, and they are written either in JavaScript or using WebAssembly in a certain node that Web Audio proposes for building a Web Audio graph that will process the sound. So you can use WebAssembly too. But so far there is no standard, no host, no programming model, nothing for reusing existing code, except of copy and paste or including a library or whatever. So what we did is that, So this is a picture of the main digital audio workstation on the commercial native market. And this market is nearly 30 years old, and you can find thousands and thousands of plugins. And this is how the economy is working in this market. And they've got 4 competing standards for plugins. So when you are a developer, it's quite complicated to port your software so that it's compatible with all the digital audio workstations. So in early 2018, with some other researchers and developers, we started to work on an open plugin standard for web audio. So to make it short, we looked at all the existing standards. We looked at some open source standards too, and we tried to make something that will bring both native developers, because this is where they are today. 99% of people who are making computer music software are doing native. Also, we wanted to bring low-level DSP developers. So there are some domain-specific languages that are used for programming DSP code, compiling to dedicated boards, and so on. And also attract web developers. I was more a web developer than a native developer, so we also teamed with some people well-known on the computer music web scene, and we try to make this standard. So the first thing we noticed is that the existing standards are not web aware. So we wanted a synthesizer to have a URI. Please, I want this in my web page. I want this in my web app. I want to get the DSP code and use it in my own application using the URI. So that means dealing with asynchronous events, dealing with packaging. So we are talking about web components, JavaScript modules here, and also propose some guidelines for publishing and reusing remotely or locally these components. So this is a picture of one of our flagship demo that is called the virtual pedal board for guitarists, because we started with guitar effects, but as you can see, we've got synthesizers now, and here you've got all these things wired one into another, but some are coded in Faust. This is a domain-specific language, cross-compiled into WebAssembly. You've got C++ synthesizers that have been cross-compiled to WebAssembly. You've got pure JavaScript effects here, and all these things, they live together. So here is a small demo video of this application.
Okay, so once you open,
yes.
add any other effects,
No,
and you can connect it to another.
so you drag and drop.
Adjust the panning.
Sorry, I'm going a bit. I wanted to find. Let's try a lot. So I'm not showing you everything, but. Or you can. So you get the idea. So this is what we've got today. So we designed this web audio plugin standard. So then we can include things written in C, C++ using some toolchain, some domain-specific languages, and we are extending it to other existing languages like Max MSP. It's not DSP, it's MSP. That is also very popular. You've got also Pure Data and other standards used by the web audio developers, audio developers. So what I meant by something easy to package, to distribute, to reuse, and web-aware. Here you've got it's a GSBin example with some JavaScript. So you are using the URL. Look at the load plugin thing. You give the URL, plugin.load, then you've got the DSP node that you can connect to your web audio graph. And you can also do load GUI. Then you got an HTML root element that is the web component itself, and you display it in the web page. So this is running real time. So I'm just entering the URI of a web audio component. Sorry, build it. It's loading. It's displaying in the web page. I can turn it on. Or I can try another one. So they are just loaded on the fly, on demand here. More funny one. Okay, so here you saw two things written in JavaScript. One is hybrid mix of JavaScript and some audio nodes inside written in WebAssembly, and so on. So as it's easy to load them, this is a commercial digital audio workstation that is running on the web called Amped Studio. So we teamed with them for designing the web standard. And here you can see the same web component inside their software, and you can record your guitar tracks using that. And here you see Soundtrap, that is also another commercial digital audio workstation. And during the last web audio conference, Andrew McPherson, the main developer, just in a few minutes managed to load our plugins inside. So what I'm doing now with people who wrote the first editing language is that it's also a nice demo for WebAssembly, because here you've got an IDE, and there is a first compiler that has been compiled into WebAssembly that is also running in the web page. So you've got first code for writing some DSP. You can run them. You can try here directly in the browser the plugin. Well, let me just try to. Okay. Okay. Okay, the sound file is not so so interesting, but what is interesting is that then you can we embedded the GUI builder for writing the component I showed you. So you can. I'm not going to make a very nice GUI now, but you can start. Designing, changing the model of your elements, change the style of the knobs, etc., etc., and you publish that. Okay, it's still an ongoing work, so this is why I'm. Okay, and it's published on a remote server. So for now, it's here. Let me check the name. It's called Game on Web Plug. Game on Web Plug. Yes, and this is what has been generated. It's a web component with also a web page for loading it and testing it. It was a distortion effect, this one, a fuzz. So you see in a few clicks, and this is a WebAssembly running in the browser. So what we're doing now is that we will automatize this to publish it on a public web server and add documentation, thumbnails, and things like that. And once your plug has been published, then you can try it with other hosts. So this is okay. So I hope the server is online because this one is in France. Yes, no. Demo effect. Yeah, oh, it's loads. Great. So this host is scanning remote repositories, getting a JSON description of all the available plugins, and then you can just drag and drop your plugins. The code, this one is coming from Sweden. Please work. No. Yes. Okay. The network seems to be slow. I don't know why. Okay, give me another chance. Normally it works. Well. Please, please, please. Okay, let's try again. Maybe with a smaller one. Yes, this one worked. Okay, normally the synths are working, but as this is coming from a repo in Sweden, oh yes, it worked. Okay, so here you've got a synthesizer, you've got an electric guitar amplifier, so you can connect this thing, you can chain, this is a guitar tuner by, it's original Chris Wilson code. So then you can connect all these things together. Let me try this. Okay. Yeah, and when it's connected, then you can try. So here is a. Okay, so I will stop the demo, but you can plug MIDI keyboards, MIDI controllers, you can plug your electric guitar, and you can wire, make some routes for the audio signal and MIDI signal because we extended this to also deal with MIDI. So, of course, we propose a SDK on GitHub that is free, comes with dozens of plugins. And we've got some online testers because as plugins are web components, they can be tried, tested, loaded online. So, for example, these are the thumbnails of the plugins that are available on our own server. And these are the ones that are available on the server that is located in Sweden. So if you click on it, and normally, yes, it loads. It passes the test with some errors in this case, the unit test, you see, and you can try them. So it helps developers testing their plugins and so on. So I don't have time to show you all the different testers that we've got. So where are we today? We've got a SDK. We've got some groups of developers, not enough working with that, helping us develop. And we support the C++ chain. They are the guys from Sweden that are in charge of that. And we've got a fast online IDE for making directly low-level DSP algorithm work and become web components, including the GUI. And of course, you can develop using JavaScript and pure and the classic web development tools. So, can we make a Rocksmith game with that? So Rocksmith was a game by Ubisoft where you plugged your guitar into your console or your PCs, and it was like Guitar Hero but with a real guitar. So yes, it's possible because we've got good low CPU ARM simulations and effects. What I showed you on the Mac, I tried with 18 different amplifier simulator in parallels, and it works. So we can get efficient solution for that. Pitch detection, maybe it needs to be reworked a little bit, but we've got a very good tuner, for example. But there is a problem, it's the latency. So playing guitar real time on a Mac, or recording voice, or recording using digital audio workstations is okay on Mac OS 6, but as I will show you, we still have some problems with, this is how we measure the latency. We put a microphone on the guitar, we just knock the guitar, record what is going out of the sound card, and just check, check the offset between the left and right channel, because we record input on the left and output on the right. And what we've got is this is what I call the real latency, between 18 and 23 milliseconds on Mac OS 6 with all the different browsers, except Safari. Firefox has a small problem right now. I talked with Paul Adeno. Normally it should be with the same, exactly the same values. But on Windows, it makes this unplayable. I mean, when you are above 30 milliseconds, it's really uncomfortable to play guitar real time. So with all the last versions of the browsers on the up-to-date Windows, I managed to get 81 or to 100 milliseconds. But I talked with a web audio working group that said that normally there is a solution that is always already shipped in Chrome Canary, and the code should be ready soon in Firefox. But for this, you need the browser to find the right driver at the OS level. And I talked with David and Raphael, and it's not clear when the driver has been found or not found. And normally we should have in the Web Audio API a property of the Web Audio context called output latency that should give clue for that. Like your application might say, something is strange, you might have the wrong driver because the latency is too high. But so far it's not implemented. So I think we need to maybe to do some work here to make this more consistent. And when I work with the music schools, some of them are online music schools, and they say all of our customers are on Windows machines. So because they are teenagers and things like that. So I think I'm talking about that because we are at Microsoft home. I'd be so happy to have this thing work well on Windows.